Hey guys, this is Wenhe and you can also call me Eric. I'm from Alibaba F2E F4X team, and today I'm going to present Pipcook, a artificial intelligence, deep learning / machine learning, with JavaScript library. And so let's first look at the agenda. So we will basically introduce the background and what is Pipcook, the design philosophy of Pipcook, some use case and capability of it. And finally, we'll look into the future to see some future plan of Pipcook and what we can combine with the web standards. Let's look at the background first. We know that when we talk about the software engineer, we are talking about maybe graphic software engineering, interaction, compiler, virtual machine, something, and machine learning software engineering. We know that software engineer can transfer from one end to another. Let's say front engineering for specific example. With the help with nodejs, a front engineer can also act as a background engineer. And so we have this kind of question. Is there a library of frameworks can help us make such a transformation for front engineer to become a machine learning engineer? And with this kind of vision and paradigm, we made Pipcook, a framework that helps a front engineer like us become a machine learning engineer. Now, through this kind of transformation process, a front engineer will know how to define model, how to train and evaluate a model, and finally how to deploy a model. So let's look at closely about what is Pipcook. So Pipcook is a front-end oriented machine learning framework. We designed a concept called pipeline, and it helps developers to define their deep learning model quickly. And Pipcook provides two kinds of user interface. One is Pipcook Tools, and it's a CLI-based interactions, and another is Pipeboard. It's a built-in GUI management tool and allows users to perform pipeline operations conveniently. So let's think about the design philosophy in terms of the architecture and how we design it. So first of all, we define a pipeline as a function, and pipeline can take a set of plugins as the parameters, and the output of pipeline is essentially our model. And let's look at the big picture of how we process the data and get the model. So at the very beginning, we get the data collect node, and right now we support two kinds of data source. One is visual in the Pascal work format, another text in the CSV format, and we put the collected data to a data access node. And basically, data access is trying to converge different data into a union instance, and then we put this data access output into the dataset process, and dataset process will run the process in terms of the whole dataset. And after that, for each specific data sample, we will run the data process. And after this kind of long data processing stage, we will get a unit data set. And after we get the unit data set, we can also define a model in the model define plugins. And with the unit data set and the model defined, we can just train a model and evaluate the model. And if we got a really satisfied result, we can just deploy the model. So this screenshot is just about a simple pipeline. It's about collect the MNIST data and process it and do a MNIST classification in the TensorFlow. As you can see, just within like no more than 40 lines, you can define a whole process of collecting your data and training your model. And after you get the pipeline, you can just run it within a single command. Pipcook run and whatever the JSON file is located at. And after that, you will get the output. So output contains basically 4 parts. The first is logs. Logs contains everything that comes out during the training and the evaluating process. And the model is just as the name suggests, the deep learning model. And index.js And if you run the index.js, you will start a service, and this service have your host model, and you can just pipe the whatever the input is and get the predict result. And metadata and package JSON, this kind of, as their name suggests, well, it's just about the metadata and some package things. And in terms of how to write, just cd to the directory and running npm install to install the essential packages, and run the node command. You can just start service and pipe the data in and get the result. And so we also introduced Pipeboard. As you can see, Pipeboard as a GUI tools, it helps you to manage and change the jobs and pipelines easily. And yeah, let's talk about the use case and capabilities here. And one use case in our internal community is it combines HTML components detection, segmentation, icon classification, layout generation. And we make a product called ImageCook. And the essential feature of the product is we can feed a screenshot and get the code output directly. And here in the demo, we feed a screenshot of a form table. And after a few seconds of process, you can see from the screenshot that we get the code directly from the screenshot. Yeah. So what Pipcook can do right now? So Pipcook allows you to train model in the following tasks: basically text classification, text generation, image classification, object detection, segmentation, and style transfer, with different kind of like sub models. And you know that Pipcook is an open source project, so this list will get longer and longer as the community keep contributing to it. And finally, we want to point to another thing, that we make a library called BOA, BOA, that could borrow the flourish ecosystem in terms of deep learning and machine learning system in Python to JavaScript directly. That means as a JavaScript developer, you don't need to learn about Python syntax or don't need to worry about Python syntax. You can just use the Python library in the JavaScript format, and that is amazing, dude. And finally, we will introduce the future plan and some kind of web standards that we are concerned about. So as you can see that Pipcook is a training-oriented library of the frameworks. So we are also concerning about the browser training, because we want to move some kind of training job to the browser. And so the first thing comes into our mind is WebN API. If we can have a more generic WebN API, that means that the possibility of shifting some training to the browser get larger. Another thing is that about the training and inference performance, and this kind of thing determines whether we can do this kind of like browser training or browser inference on the browser at a like business level. And another thing about the model format, we are thinking about that, is there a like web friendly like model format? Is that TensorFlow.js format? Is that like h5/pb format? Or we can combine them together to get their pros and cons. And finally, we are thinking about the model storage. As you know that the deep learning model essentially is a graph with some weights. And if we can come up with this kind of like, we say that we call it neural network oriented database. And basically it's a graph oriented database that stores the information in a graph format. And in this way, we can definitely reduce the serialization and deserialization overhead when we are just trying to put some like deep learning models into the IndexedDB or some other regular database. And that's it. And this is our presentation. Thanks for listening. And if you still have any question in terms of the Pipcook, if you are interested in Pipcook, and just don't hesitate. Come with us, hit us up, and come into our community. We are really welcome for any suggestions, discussions, and collaborations. Thank you.